Okay, so this video will be looking at some questions and some exercises and how we determine the oxidation number. And in this case, we'll be trying to determine the oxidation number of nitrogen. Nitrogen is obviously with the symbol N, and let's see how that works. So NF3. We know that fluorine is one of those cases where the ionic charge is always -1. So, and since we know that the overall charge is 0, that means the sum of the elements' charges, individual charges, would add up to 0. So with fluorine being -1, that times 3, we'll get -3. Therefore, nitrogen has to be +3. Okay, NO. Again, kind of similar. We'll have oxygen being -2, as it always is, and thus making nitrogen +2. Here, oxygen being -2, nitrogen being +2. However, that is N2 equals +2. And since we have 2 nitrogen atoms, obviously that would be divided by 2, and overall charge for nitrogen would be +1. N2O4, -8, -4 each. In total, it's +8 and -8, which would cancel out. In this case, sorry for the bad handwriting, but it's N2H4. Hydrogen has a charge of +1, so therefore it would be +4, and this would be -4. Divided by 2, meaning -2. An overall charge of -2. So we see here this is the first time that nitrogen has been a negative oxidized number. Finally, we have NO2 negative. This signifies this is the first ionic compound we have here, because everything else has been with an overall charge of 0. This is the only one which has an overall charge of -1. Therefore, the overall oxidation number sum would be indeed -1. So we have here 2 oxygen atoms, which means +4. And whilst we might have previously done +4 for the nitrogen here, that isn't correct, because then we would have an overall charge of 0, but we have an overall charge of -1. Therefore, the overall charge for nitrogen is +3.